Hello friends. In this video we will cover a use case where you have two motors and you also have a sump tank. One motor is responsible for to top up your overhead tank from the sump tank, and we call it as a primary motor. And there is another motor which is responsible for filling up your sump tank either from Borewell or from the municipality water. So to automate this case, we need a dual motor solution from the DigiPump. And in this panel, we will provide the connectivity for both the motors. How that will be provided in terms of the wiring, we will cover later in the when we will explain the wiring diagram. But this is how it need to be connected, like both the motors is connected to the panel, and there will be total 4 sensors in this case that will be connected to the panel. Two sensors in the overhead tank and two sensors in the sump tank. The overhead tank sensor will indicate when it is empty and it is full. Based on that, your primary motor will be started, and the sump tank sensor will indicate when the sump tank is empty and when it is full to start and stop your secondary motor. Not only just that, but it will also synchronize between these two motors. So suppose there is a case where you have an empty overhead tank and also empty sump tank. Now the question comes, since the overhead tank is empty, will my primary motor will start or not? So since your overhead tank is empty, but your sump tank is also empty at the same time. So even we start the primary motor, it cannot fill up the overhead tank because sump is empty. So this synchronization will automatically happen and it will not start your primary motor. Instead, it will start your secondary motor so that your sump tank can be filled first. And once the sump tank is full, then it will start the primary motor to fill up your overhead tank. So all this synchronization between two motors is done automatically through our controller. You do not need to worry about that. So there are total 4 sensors required to be connected, but in this particular solution the overhead sensor will always need to be wireless, whereas the sump tank sensor can be wired or wireless. So the two sensor will go to the overhead tank, which are wireless, and two sensor will go to the sump tank, which can be wired or wireless. Let's see how these sensors can be connected to the panel. Let's see the sensors connectivity and what are the range of these wireless sensors, etc. We will cover now. DigiPump provides you two types of connectivity to connect the sensor. One is the wired connectivity, another is the wireless connectivity. In the wired connectivity, you need to bring 3 wires from the overhead tank up to the starter panel, and these 3 wires can be connected either through the 3-core cable or Cat5 Cat6 cable using 3 wire socket. The second, before we go into the wireless, uh, here we describe how they are connected with the electronics. What are the marking? So if you see on the electronics, there is a marking common: overhead empty, overhead full, sump empty, and the pipe sensor. So here we have only shown for the two sensor in the overhead connected to it. So the black wire, which is a common wire, that is joint on the rooftop itself, and from there you can bring only one black wire up to the panel, and the blue wire of the empty that need to be connected on to the OH empty, the brown wire of the full that need to be connected on to the OH full. This is how you connect the sensors in the wired case. In the wireless, you will have two components. One is your starter panel, as it was there in the wired connectivity, but here you will have an additional wireless transmitter which will transmit the sensor status wirelessly to the receiver, which is your starter panel. So here you have another transmitter which will be installed on the tank itself, and you have sensors connected to the wireless transmitter. The common of both black wire of both the sensors need to be connected to the black wire of the transmitter. The blue wire need to be connected to the red wire of the transmitter, and the brown wire of the full need to be connected to the green wire of the wireless transmitter. This is how you connect the wireless sensor, and it has a long range wireless connectivity, so you can have your uh, tank maybe 5 to 10 floor easily, wherever your tank is located in the center of the roof or on the corner of the roof, it can cover that. It can cover more floors also, maybe 20-50 floors also, but for that you might need to install a transmitter and receiver in such a way that they can face each other. The dry run sensor, which is sump empty, and the pipe sensor, they can be either wireless or they can also be wired. So we provide you three different options, like you have all four wires fully wired, then you can have a fully wireless where all four sensor are wireless, and a hybrid where you have the overhead as wireless and the dry run sensor as the wired sensor. Why we provide this? Because with the wireless connectivity, it adds some cost to the solution because of the wireless transmitter and the chip used for the wireless transmission. So when you use sump empty and or the pipe sensor as to be wireless, so in that case you will need, in the fully wireless solution, you will need two transmitter, and the two transmitter basically add to the cost of the solution, because overhead will transmit separately and the sump empty sensor transmitter will transmit separately. So it's up to you which solution you want. Now let's discuss the power wiring. How will you connect the phase, neutral, or the power of your motor, RYV wires of your motor? Friends, in this diagram, we have shown you how you can connect two motors with our panel. So your submersible motor will directly be connected to our panel with the RYV wires, which are the output wires. On the input, we have L and N points, where you need to give the main line supply as a phase to the L point and neutral to the N point. So your submersible motor, which is a secondary motor, we call it as a secondary motor, used as the backup when the primary motor is not able to fulfill your overhead tank. So your secondary motor will be connected to R by B points if it's a submersible motor. And your monoblock motor, which is assuming that it's already connected to the some socket in your existing setup. So to supply to that socket will be controlled through our panel. So the phase to the 3-pin socket will go from the P1 point, and neutral will go directly, the same neutral which is shared from the main line will go to the your socket neutral point, which must already be there. So only you need to connect the phase from our panel to your socket, which is controlling your monoblock motor. So this is how you complete the dual motor wiring. One motor is directly connected to our panel, and the monoblock motor is connected to the socket, but socket is controlled by our panel using the P1 phase. So once you connect it, let's see what all features are available for you to use in our solution. Friends, DigiPump provides you many inbuilt features to help your automation, but we are going to cover the key features only, because otherwise this video may become too long. So let's start with the features. Automatic start, basically your pump starts whenever the water level goes below a certain threshold in your tank. Automatically stop whenever the tank is full, it will automatically stop the motor. Scheduled start and scheduled stop. So basically you can start the motor at a specified time, and you can also, if you want it to be stopped at scheduled time, you can also have the stop also through the schedule. Dry run protection we provide through the two sensors. One is the sump empty sensor, and one is the pipe sensor. So sump empty sensor is used when you are having the sump tank and you want to make sure that even though your overhead tank is empty, and since the sump tank is also empty, it does not run the motor infinitely in the dry run condition because it cannot fulfill the tank because sump is already empty. Similarly, for the pipe sensor is being used when you are using the municipality water, for example, like the water is not coming but your tank is empty. So it should not happen that your motor keeps running to fill the tank, but tank cannot be filled because the water is not coming from the municipality. So to protect against those conditions, the dry run protection is available. We have a voltage protection. The voltage protection is for the low voltage and the high voltage condition. So whenever your voltage goes above 265 volt or the input voltage goes below the 165 volt, then the voltage protection triggers and it will stop your motor. Similarly, we have a current protection. By default, we set it to the upper threshold of 14 ampere. So if your motor start taking more than 14 ampere, it will switch off your motor. Apart from the automatic start and stop, sometime you may need to override those controls and you need a manual control. So we provide a switch in the panel that through which if you can just press it, it will start the motor, and if you press it again, it will stop the motor. So manual switch override is also possible apart from the automatic. We also provide a countdown timer. The countdown timer basically helps you when you have a condition. For example, like whenever I start a motor, it should automatically switch off with, in 30 minutes, no matter what. So whether the motor started with from the schedule or started from the sensor or started manually, it will automatically switch off after those many minutes or hours, whatever you have set into the countdown timer. So the big question that customer usually have in their mind, and whether this works without Wi-Fi or does it need internet and the Wi-Fi. So I would like to clarify in very clear terms that the complete automation works without any Wi-Fi, without any internet, without any Bluetooth or a SIM card or anything, because it senses based on the sensors, and based on that sensor activity, it basically start and stop your motor. Even the schedules that we have, timers we have, does not need internet. We have a built-in clock and the battery to maintain the clock. So the timer also works without any internet or the Wi-Fi. So the question is, if the complete automation works without Wi-Fi, does it has the Wi-Fi support or the internet support? If yes, what is the use of that? So if you have the Wi-Fi in your home and you can provide the internet to the device, although it's not required for the automation, but you can have additional features that might be useful for you. Let's cover what are those features that are available when you can provide the internet to the device, although internet is not required for the mandatory automation. So when internet is available, you can get the notification in the app. So whenever the motor gets started or stopped, you will get a notification in your app that motor has been started at this particular time and at this particular date. Not only just the notification, but it will also come with the trigger level detail, whether motor started because of the sensor activity, sensor detected that water was low, or somebody pressed the switch manually, or was there any fault condition like over voltage that caused it to be stopped. So all those details comes in the notification. Anytime control is basically you can control the or you can check the status of the motor from anywhere if you have the internet connected to the panel. So with that, even if you are in different city, you can check the status of your motor. You can check the status of your sensors anytime sensor check. Not only the status of the motor, you can also check the status of your sensor sitting in different city, sitting in different country, in fact. Because through the internet it can fetch the status of the sensor, and it can fetch the status of your motor, whether it's running or not running, or the empty is showing the tank is empty or not. It also provide the parameter update facility with the internet, like from remotely you can change the parameter. For example, like the current threshold that we have set from the factory is 14 ampere, but your motor takes, for example, 8 ampere only, and you want to set the upper threshold as 10 ampere for protection, that whenever it takes more than 10 ampere, the motor should be automatically switch off. So that is possible through the setting the parameter into the device. Voice control is also there, but we do not see much of the applicability of the voice control. But yes, if you have internet, you can also give the voice commands to start and stop your motors to Alexa or Google Assistant. The important feature is energy monitoring. It provides you the power consumption details of your motor, like how many units or how many kilowatt hour units consumed today. So for the current month, it shows the date-wise consumption, and for last 11 months, it provides you cumulative monthly basis consumptions. So that's the energy monitoring that you can have here, and you get to know how much power is consumed by your motor. If you have any further queries, you can contact us for the technical queries on 8130345141. And if you want to resell it, you want to install it, or you want any sales partnership, you can contact on 9811682214. Anytime you can visit us on our Vasundhara office. Thank you.